Hi, on today's TekTips, I'm going to give you an overview of the ClearPath Motor Setup Program, MSP. What is MSP and why do you need it? Well, to start with, MSP, which stands for our very creatively named Motor Setup Program, lets you set up the settings and options for ClearPath MC and SD series motors. If you have a ClearPath SC series motor, you'll need to use our ClearView software, not MSP, although both programs are used for similar purposes. So what does it mean to set up a ClearPath motor, and what else does MSP do? Well, first of all, ClearPath is a servo system, which means that you can tweak its settings to optimize its performance for different loads and mechanical systems. MSP is used to auto-tune and tweak ClearPath settings for optimal performance. Second, ClearPath is used by OEMs who want to build the same machine over and over again, and who want to copy their optimized settings into future ClearPath motors. MSP is used to save and to load these optimized configuration files. ClearPath MC and SD series motors do what they're set up to do based on digital signals they receive from an external device. For example, you can control ClearPath with digital outputs from a PLC or a microcontroller like Arduino with simple switches, knobs, and buttons, or with step and direction signals from a digital motion controller, also known as an indexer. ClearPath's behavior in response to these digital signals is determined by its mode of operation. ClearPath is a very flexible product and can be configured in a number of different ways depending on your application. So the third thing you do with MSP is to choose your desired mode of operation. At a high level, this means choosing whether you want to primarily control speed, torque, or position. Our website has videos that show in detail how each operational mode works. But before you wire in your external device, the fourth thing you can use MSP for is to emulate the external device by overriding ClearPath's hardware inputs. This allows you to test and exercise your ClearPath motor and make it move before you've connected any of this external hardware. And finally, MSP has many built-in diagnostic tools that will help you make measurements about the performance of your system, including measurements about the motor, the connected mechanics, and the control signals. For example, you can view the precise amount of torque required from the motor as a function of time. With some practice, you can learn many important things about the performance of your system. You can also troubleshoot many mechanical, electrical, and software problems you might run into with your machine. I'm going to first run through the MSP UI and explain each section, and then I'll double back and make a motor spin and show you how MSP is used in real life. As this is an overview video, I won't be going into great detail, but it should be enough to get you started. Let me first talk about the menu bar. I'm going to go over it really quickly because there really isn't that much that you use the menu bar for. But there are a few things, so let's take a look. In the file menu, the main things you're going to use are the load configuration and save configuration. And this just allows you to save all the settings, your tuning settings, your velocities and accelerations and things like that, and then load them into another motor. If you're an OEM and you are making dozens or hundreds or thousands of machines, you want to be able to easily load in the configuration that you've previously created. Also, there's this reset configuration file to factory default. So if you ever really mess up and you're not sure what you did, hit this reset button here and that'll get you back to start. The edit menu is pretty simple. The only thing you're probably ever going to do in here is potentially set the motor ID, and that's just a way to name the motor so that when ClearPath gets connected, it'll tell you what the motor is and maybe what you were connected to or whatever you think is important about that motor. It'll show you that when you first plug into it. The mode menu is the way to select how ClearPath is going to operate. This is an MCPV model, so it has a lot of different modes. It's got velocity modes, position modes, torque modes. The MCVC models have a couple fewer modes than this. And then the SD series, the two models within the SD series, they're step and direction versions of ClearPath, and so they only have one mode. So if you have a step and direction model and you open this mode menu, you're only going to see one thing here. So don't be worried about that. Under Setup, you have the auto-tune and fine-tuning selections here. And when you first plug in your new motor to ClearPath, it's going to ask you to auto-tune. But you might want to come in here and retune an axis, like if you add more weight to the axis or you change something about the axis, you might want to rerun auto-tune to re-optimize the settings for the new load. Fine-tuning is a way of just tweaking the tuning, and that's pretty simple if you open it up and take a look at it. The advanced is just what it says. There are a bunch of esoteric settings in here that generally people don't change. Some people do, but a lot of these things can just be left as they come from the factory. But you can take a look through here and see what's here, and there's usually pretty good explanatory text that tells what each thing does. And obviously, take a look at our manual. There's a lot of good information in there about each of these settings. Now up here, this section here is going to change depending on which operational mode you're using, but it's going to have a lot of common settings. For instance, pretty much every mode has a speed limit setting. That's the maximum speed that the motor is going to go. It has an acceleration setting, which is the maximum acceleration that the motor will use to get up to speed. And it's got a RAS or jerk limit setting. This is a Teknic proprietary way of jerk limiting and doing jerk derivative limiting for very smooth motion. Now down here, this is actually sort of two sections in one because they are somewhat related. Up here you have the input status. So for instance, you've got the three inputs on ClearPath, the enable and input A and input B. And these are little pseudo or software LEDs that light up when current is flowing through the opto-isolated inputs. This is the enable, and it would turn blue if the motor was enabled, input A and input B. You'll notice that there's a little red triangle here, and that's not always here, but if you ever see one of these in the UI, you want to hover over it because it's going to give you some information about something safety related. In this particular case, it's saying use caution when enabling current settings will cause immediate motion, and that's because where my axis is currently located, if I were to enable it, it's going to go to, in this case, the number 1 position, which is at position 1000, and that's not where it is right now. So it will move immediately when it gets enabled, and this is just to let you know that that's going to happen. Down here you have the override input section, and that's pretty cool because it allows you, without having to wire up anything to ClearPath, to actually operate the motor and emulate what would happen if you did have the hardware connected. So you can just click on override inputs, and now you get these checkboxes which allow you to enable the motor and to articulate inputs A and B. Down here is what we call the dashboard. This gives you a bunch of important status information about ClearPath. This section here says disabled or enabled, and sometimes it will say shut down if ClearPath detected a safety situation or a situation where the motor would be damaged or potentially the mechanics, and it will actually shut down, and that would be indicated here as well. There's a little software escape button that allows you to stop the motor if you need to. It is software dependent, and it's dependent on the Windows operating system, so you can't trust it like a true sort of OSHA safety sort of mechanism. If you need that because of your particular mechanics, you'll want to hook up a hardware switch to disconnect power if need be. This over here is indicating what the RMS torque level of the motor is. And you'll see that currently it's at 0%. And that's because the motor's been sitting and resting for a while. And so over time, the RMS, that's root mean squared or sort of average torque that it's used in the last few minutes, let's say. And so since it's been sitting for a while, this is set to 0. But you can also see that the maximum that it has seen is 75%. And that's since the last time it was powered on or reset. And I can double click this, as you saw from the tooltip, and that will go to the current setting. And that's nice. You can run the motor for a while and it will record the maximum that it ever saw. Here you have the position, and that's just basically a readout of the encoder scaled to user units. This you'll only see in positioning modes, obviously. In a velocity type mode or in a torque mode, this area will be blank. You won't see a position indicator. And then the velocity indicator, and that gives you sort of a short-term average velocity. Now this section over here tells you if anything goes wrong or anything is unusual, something will flash up here. Often it'll be sort of color-coded to call attention to itself, and that will tell you what's gone wrong or is potentially going wrong. And if you need further information, you just click on this little question mark right here, and that'll give you a legend that will tell you more about what's going on. So, and there still is more. If I press on this little plus button, I open up an oscilloscope that shows you a bunch of different variables that have to do with the scope. I'm going to go over this very quickly, and you're not going to see much because nothing's happening with the motor right now, but when I'm all done, I'm going to give you a demo and all of this will make more sense. Right now, it's showing me the commanded velocity. This is what we're telling the motor to do, but I can also look at actual torque being used, and this is all as a function of time. I can look at actual velocity, velocity error, the measured position, the jerk, the acceleration, all sorts of things, and I'm not going to go into those right now, but it's you'll find it very, very useful. It's got a time base just like every scope, and this is just the number of milliseconds per horizontal division, and that can be scaled how you want. And then the range, and the range setting is dependent on the variable. In this case, we're measuring commanded velocity, so the range is in RPM. And what this means, what the 4,000 means is that the top of the screen represents plus 4,000 RPM. The bottom of the screen represents minus 4,000 or 4,000 in the opposite direction. And then the center for every variable always represents 0 of that variable. So in this case, 0 RPM. We've got some cursors. We've got ways to store traces. We've got different ways to trigger on the command. And this is all beyond the scope of this video. Different trigger modes, etc. Okay, but there's still a little bit more. If I click on this button here, this is what we call the strip chart, which adds additional information that complements what you'd see in the main scope. So let me get on to a demo, and you can actually see how all of this fits together in the real world sort of situation. This is moved to absolute position 4 positions. And as you might expect, there are 4 settings, 4 positions here. My first setting is at the 1000 position, and that is the place to go when the A input and the B input are both off. I move to the 5000 count position when the A input is on and the B input is off, and so on. Those positions are encoder counts in the stroke of the axis, and then that's with 0 representing the home position, and I'm going to show you that right now. Homing gets set up with this button here. If I click Homing Setup, I open this up and it tells me that homing occurs on the first enable after power up. So as the ClearPath motor comes alive and you then go ahead and enable it, it will find its home position. In this case, for my axis, the home is a negative move or a clockwise move of the motor shaft, and that takes this axis to the right-hand side where there's a bumper that we use as the hard stop. This max travel from home setting is pretty cool because this allows me to define the limits of the stroke. This particular axis actually has about 34,000 counts of total stroke, but I've entered 32,000. That means if I ever accidentally were to enter a move position of, let's say, 50,000 because I meant 5,000 but typed in an extra 0, the software would know that that's outside the boundaries and it wouldn't let me execute that move. So you've got your homing speed, your homing accel and decel, and then the hard stop torque limit. This is an alternate torque limit that's in effect only during the homing move, and it allows me to use less than full torque when I press up against my hard stop. I'll click OK. And now, since I don't have any hardware connected to my motor, I'm going to emulate the hardware so that I can make the motor move around. I'm going to use this override inputs feature. When I click that, these boxes become active, and now I could enable the motor and I could make it move around. Now, when I first enable it, as you remember from the homing setup, it should home, and that's why this red triangle is here. This is sort of a reminder that if you hover over it, you'll see that it says to use caution when enabling. The current settings will cause immediate motion. And that means that as soon as I enable it, it's going to move, so you want to be careful about that. and it's just sort of a little reminder for safety. And the other thing is that what would happen if you didn't have a hard stop in place? The homing routine is going to seek the hard stop. So if for some reason there isn't a hard stop there, like your mechanics aren't fully built yet, you can emulate it by pressing this set home position while you're seeking the home, and that will just set your zero position wherever you press the button. So I'm going to go ahead and enable access now. And you can see that it's moving toward the hard stop. And so you may have noticed that when it hit the hard stop, there was this torque saturation indicator that came up briefly. And that's just telling you that the homing used full torque and detected that the hard stop was there. It saw that the axis had stopped moving and was using full torque. And it does a couple other things to ensure that it doesn't falsely detect a hard stop and that it's repeatable. And then it immediately moved to the 1000 position. And the reason for that is that my emulated inputs, A and B, are both off, and that corresponds to the 1000 position. So that's why it's now sitting at 1000. So let's make a couple of moves here. If I turn the A input on, you can see that I immediately move to the 5000 position. And that's because the second position here, A on and B off, is defined as the 5000 position. If I turn B on, likewise, I move to the 30,000 position because that's the A on and B on. Similarly, if I turn A off, I move to the 20,000 position. And if I turn B off, I move back to the 1000 position. So it's a very simple mode, but great if you have a limited number of positions that you want to move into, and it's trivial to write software to do this sort of thing. And that's how this mode works. Now, I told you I was going to tell you a little bit about the scope, so let's play with that right now. Okay, so to use the scope, what you first want to do is make sure that the trigger mode is not stopped like this. I'm going to click normal. I'm not going to go into the differences here. That's on another video. And then I'm triggering right now on the start of any command. There are many different ways to trigger, but this is a good one. Right now, my variable is commanded velocity. We're going to look at what we're going to tell the motor to do when we change the inputs. What does that actually correspond to? Time base is 100 milliseconds per division horizontally. My range is 4,000 RPM, so the top here represents 4,000. This is 0 RPM, and this is minus 4,000. So when I click this A input and move to position 1000, I trigger and I get this little triangle. And basically what this is saying is I was sitting at 0 RPM, and then I ramped up, got almost to 1000 RPM, because remember this is 1000 RPM per division, and then ramped back down and stopped. And the move took just about maybe a little over 100 milliseconds. Do input B. See, that's a much longer move. If I turn input B back off, you can see that's a negative move. And then if I turn input A off, that's a small negative move. Let me make that longer move again by turning on input B. And now let's say I want to measure the length of this. Well, I have these cursors that I can use. If I press this cursor button to bring the cursors onto the screen, you can see I have a magenta colored cursor A, and I have a blue B cursor. If I just put that on the end of this move. Now here down in the strip chart, you can see something interesting. The actual end of the move is right where I have the cursor. It's not actually here where it might visually look when you're looking at just the ramp down, but because the very end of the ramp happens gradually because of the RAS trying to slow the move down at the end very softly to get a real smooth touchdown. The real end of the move is here, where you can see this move trace shows the end of move. You can see that the input B went positive right here at the trigger point and stayed positive that whole time. My enable's been true and my output has been true the whole time. Those are other things that you can see on the strip chart. And I have no drive events. I have no exceptions or anything, which is what this trace here is indicating. So one other neat thing that I can do is I can save this trace. I can come over to trace storage, and I have two trace storages, store 0 and store 1. If I click that, I've now stored that trace. And if I move back to where I was, you can see this is the move back, the negative move, and this was the positive move, and they're mirror images of each other, obviously. So let's just see what happens if I make a faster move. I'll change the speed limit to, say, 3,000, and I'll double the acceleration to 40,000. And now I'll make that move again. You could hear the difference, and now you can see the difference. I get up to a much higher speed. I didn't hit my speed limit of 3,000. I got to maybe 2,500. And my move was quite a bit faster. And in fact, if I put my B cursor on the end of that move, I can see over here that my A move took 252.9 milliseconds. My B move took 160.2. And a delta, a difference of 92.8 milliseconds. So that move was a little less than 100 milliseconds faster. I can also use these cursors to measure amplitude. If I put this B cursor right on the peak here of this move, I can see also here that that got up to 2,530 RPM. Now let's see what happens if I increase the acceleration even further. I'll go to 50,000. And make a move. And now I don't know if you saw that, but this torque saturation light came on. It goes out after a little while because it was a momentary event. Torque saturation means that the motor needed 100% or over 100% torque to execute the move. And that's a little bit more, right? We're exceeding the capabilities of the motor by telling it to accelerate at 50,000 RPM per second on this particular axis with this load. The other thing you can see is if you look down here, you can see these little turquoise blips, and I remember turquoise T for torque saturation. And you can see there were actually two events. We only heard one blip, but there are actually two discrete events, and that's sort of neat that you can see that. Now, if you forget that T stands for torque saturation or turquoise stands for torque saturation, you can click on this little question mark button here and bring up a legend. And you can see for drive events, torque saturation is blue. If it were pink like this, that would mean an overspeed event. If you got torque and voltage saturation, it would be this brown color and so on. I'll close this. So let's look at one more thing. I'm going to turn this trace off so it's not distracting us. And I'm going to, well, let me store this trace here. I'll store this one because I'm going to overlay it with looking at actual torque. So now I have actual torque as my variable. My range is in percent of max. 100% of max is the top, minus 100% of max, meaning 100% of max in the opposite direction, is at the bottom, and 0 actual torque is the middle again. So if I make this move again, I get my torque saturation. And you can see that, in fact, I am peaking out here at just nicking 100% here and nicking 100% down here. And that's the reason for this torque saturation. So you can see very visually over the course of this move that the torque is just hitting its limit. If I go back down to where I started, or where I went to at the second time, and go back to 40,000 and make this move again, you'll see I'm only using, maybe a maximum of about down here 75, 78%, and I can put my cursor on that, say right there, and look over here, it's actually 79 or minus 79% of max. And that's a reasonable amount of headroom for a move, unless I expect that this axis is going to see a heavier load in the future, or that the friction might go up over time, but this is a reasonable amount of design margin to have. So you can probably tell that there's a lot more to play with here, but this TekTips overview should help get you started. If you found this video to be helpful, please click the thumbs up like button so other ClearPath users will know and be able to learn from this. If you want to get notified whenever we release a new video, click the Teknic logo right now to subscribe. And here are some other videos you might enjoy and also find useful. Finally, please feel free to comment and ask questions. We greatly appreciate your feedback, and we welcome the opportunity to answer any questions you might have.